Hi everyone, Mary here, and we are going to do an elastic potential energy problem. Here goes. A block of mass 0.2 kilograms is attached to a spring of negligible mass. When the spring is stretched 10 centimeters by a force of 54.5 newtons, what is the spring constant for this spring? So for the very first part here, I am going to use Hooke's law, and Hooke's law is force equals spring constant K times displacement from rest position, x. I want to find my spring constant, so K will be equal to force divided by how much it is stretched, and the force is 54.5 newtons, and it is stretched 10 centimeters, but I've got to convert this to meters, 0.01 meters, and I end up with 545 newton meters. Newtons per meter is my spring constant K. Second part of the problem says that the spring and block are stretched horizontally 4.5 centimeters from rest and then released. When it moves back through its rest position and there is friction between the block and the table of 0.300, I want to know its speed. So let's draw a little picture of what's going on. My block is sitting on a table, and there's my little spring. Now, this is the rest position. This is the position of the block when it is under no excessive tension. The block is then, and the spring are then stretched, so it moves away from rest position 4.5 centimeters. So this is my x, 4.50 centimeters. And then the block is released. So it's pulled back and then it's released. When it releases, the block is going to go like this. It goes from a stretched position through high velocity back to compressing the spring, and it's going to go wee, 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 wee until energy is totally lost to friction. Now, when it is at this position, it has a lot of spring potential energy. As it moves back towards that rest position, the energy is going to convert from spring potential into kinetic, because the block is going to have some velocity. And in moving this 4.5 centimeters, it will also do some work against friction. And I am going to use conservation of energy to solve the velocity when it springs back. So here goes. The spring potential energy when it begins is going to be used to do two things. Some of it's going to be converted to kinetic energy when it springs back, and it's going to do some work against friction. Now my spring potential energy equation is 1/2 kx squared. Kinetic energy is 1/2 mass velocity squared, and work is the force you're working against, which is friction force, times the displacement x, and it's the same x here and there. So let's throw some numbers in. 1/2 K. K, my spring constant, is 545 newtons per meter. It's 4.5 centimeters. I can't mix up my meters and my centimeters, so 0.045 meters quantity squared. And if I do the math on all of that, I get 0.552 Newton meters, which is work or energy units, equals my kinetic energy, 1/2 the mass of my block, 0.2 kilograms, times velocity squared, plus friction force. Now, as you remember, friction force is mu times normal force, and if it's sitting flat on a surface, normal force will be equal to force of gravity. So friction force will convert into mu, mass, acceleration of gravity, times how far it moves against friction, and that is my 4.5 centimeters. So let's keep going. Half of 0.2 is 0.1 kilograms times v squared, and I'm looking for v. This is my unknown. My mu is 0.3. My mass is 0.2 kilograms, and just because I'm running out of space, I'm not writing down all of my digits. Gravity is 9.8, and how far does it move? 0.045 meters. So when I do all of the math on all of that wonderful stuff, I get 0.0265 joules. And let's simplify this. So this is going to be 0.552, a newton meter is a joule, equals 0.1 kilograms times V squared. So I'm going to get all of these on one side of the equation. I'm going to subtract that from both sides. So 0.552 joules minus 0.0265 joules equals 0.1 kilograms times V squared. So my velocity is going to be the difference here divided by that. So velocity is going to be the square root of 0.552 joules minus 0.0265 joules divided by 0.1 kilograms, 0.100 kilograms, and that ends up being a velocity of 2.29 meters per second when it slides back through that rest position. Alrighty, see you next time.